Welcome back. In part 1, we set up the problem, built our game plan, and found all 4 velocity components. Now the next step is just plugging this straight into our 2 formulas for the AX and AY. Starting with X, so AX is V2X, which is negative 8.70 meters per second, minus V1X is negative 6.52 meters per second, then divided by the time, which is 4.2 seconds. Okay, right here, this is where a lot of people drop marks. We're subtracting a negative number, so this becomes negative 8.70 plus 6.52, then divided by 4.2. Okay, don't skip this step, write it out. Minus a negative is a plus. Okay, if you do it in your head, you might mess up the sign eventually. Okay, so this eventually gives us AX equals negative 0.518 meter per second squared. Okay, now y direction. AY equals V2y is 4.06 meters per second. Then minus V1y is negative 3.04 meters per second. Then divided by the time, which is 4.2 seconds. Then we have 4.06. As we have said, minus a negative number becomes plus 3.04, then divided by 4.2. This eventually gives us AY equals 1.69 meters per second squared. And look at these two numbers for a second. AY is 1.69 and AX is only negative 0.518. The y component is way bigger, and that makes total sense. The Falcon was going west the entire time, right? So the x direction is barely changed, but the y direction flipped completely from the south to north. Of course, most of the acceleration is in y direction, right? So now we have AX and AY, we need to put them back together. Think of it like this. We disassembled the vector earlier to make the math easier, but now we are resampling it. So here's our triangle. AX is negative 0.518. It's a negative value, so it's facing west. And AY is the vertical leg. It's 1.96 meters per second squared. Because AY is approximately 3 times greater than AX, so I just draw this leg about 3 times longer than AX. And it's a positive number, so it's pointing towards positive y, right? And the acceleration we are looking for is the hypotenuse. The hypotenuse is just the square root of the 2 legs squared and added. Good old Pythagorean theorem, right? So we have A, or the magnitude of A equals the square root of AX squared, which is negative 0.518, then squared, plus AY, which is 1.69, then squared. Let's make this longer. And this negative sign disappears once we square it, right? So negative times negative is positive. So we have square root of 0.268 plus 2.856. And this eventually gives us 1.77 meter per second squared. Now we have the magnitude, but that's only half of what we need. A vector without direction isn't really an answer. So let's figure out which way this acceleration is actually pointing. So we said theta is the inverse tangent of AY over AX, right? So this is the theta. So tangent theta is the opposite side, which is AY divided by the adjacent side, AX, right? So theta is the inverse tangent of AY over AX. And now let's plug in our values. AY is 1.69 meters per second. Then over AX, we are using the magnitudes, so we drop the negative sign. The magnitude of AX is 0.518 meters per second squared. So this eventually gives us theta equals 73 degrees. And because we use the absolute values, Theta is just a clean 73 degrees. No weird negatives, no calculator confusion. Now we just use our drawing to figure out the direction. AX is negative, so that's west. And AY is positive, so that's north. So our acceleration is pointing mostly north with a bit of west in it. So we can write the final answer as A equals 1.77 meter per second squared. And the direction is starting from west, then rotate 73 degrees towards north. Okay, now I have my answer. But before I box it, I want to do something that I think separates the students who actually get physics from the ones who are just doing algebra. Let's make sure this makes sense. Now let's go back and look at the picture. The falcon was going west and south, and now it's going west and north. Something had to push it in the northward direction to make that happen, right? So our acceleration should be pointing mostly north. What did we get? West 73 degrees north. That's a steep angle and mostly north, just a little bit west. This is exactly what we expected. And how about the magnitude? The falcon was going west the whole time. It just got slightly faster. So AX should be small compared to AY. And it is. We have 0.518 compared to 1.96. This is also expected. Now imagine you got something like east 60 degrees south as your answer. Something like this. East and south. The bird was heading west the entire time and pulled northward, and that makes zero sense physics, right? That's your sign to go back and find the mistake. There might be some mistakes when you are trying to determining the signs of the components. So that's the sanity check. It will catch the errors that staring at your math never will. Alright, let's make a quick review. We started with one formula of the average acceleration, but we realized we couldn't just subtract the vectors directly, so we broke it into two one-dimensional problems, AX and AY. Then found all four components, plugged them in, then stitched the answer back together with Pythagorean theorem and the inverse tangent. That's the skeleton. And here's what I want you to take away. This isn't just how you solve this problem. Every two-dimensional kinematic problems follows this exact same structure. Different numbers, different directions, same steps every time. Once the roadmap is in your head, these problems aren't hard. They're just a checklist. Okay, see you in the next one.